Okay, so welcome, and we are going to talk about atoms. So this is where we are, and these are your learning goals right here. You should list the 3 subatomic particles that make up an atom and indicate the charge on each part, and then know what these following terms are and what makes each term unique, what's different about each term. So just to remind you of where we're at, here we've gone through this before, but if we're organizing life, if you remember, we start at this chemical level, and the smallest stable unit of matter is an atom. That word stable is very important. We'll talk more about it. And then if you remember, you combine atoms, and you get molecules, small and large. You combine molecules together, you get a cell. Combine those, you get tissues. Combine those, you get organs. Combine those, you get an organ system. And you combine all the 11 organ systems, and you end up with an organism. So this is just a reminder that what we're going to be looking at throughout this entire homework lesson, which is Chapter 2, is atoms and molecules, but for this short segment I'm going to be talking just about atoms. Okay. Alright, so structures of atoms. So this word stable, you're going to find that there's actually 3 parts that make up an atom. So you can split an atom into smaller parts, but they're not stable, meaning they don't want to exist just as a little piece on their own. You might think of it as, I don't know, my mom used to have 2 horses, and they loved each other so much that if they were ever apart, they would fret and whinny and run back and forth and just be very upset. They weren't stable. And you could say the same things about these parts of an atom. They need each other to be stable and calm. Okay. This here is showing a cartoon representation of an atom, and there's going to be 3 parts that you see. This P right here refers to proton, N refers to neutron, and E refers to electron. So those are the 3 parts: electrons, protons, and neutrons. Now, one thing you should notice is that there are locations in this atom. This right here you might consider the center of the atom. And that means that this is the nucleus of the atom. It's called nucleus. Nucleus is a biology term for the center of something. We'll talk about a nucleus in many different contexts, but for an atom, the nucleus is the center of it. And you'll notice that protons and neutrons are here in the center. And then electrons, there's this little circular line way out here. And if you think about how the Earth orbits around the sun is in the center. Well, electron is kind of like the Earth, and it's orbiting the center. So this black line is showing the path in a cartoon drawing of an electron. Now, if you take more advanced chemistry courses, you're going to find that this is a bit simplistic, but for our purposes, this is fine to think of it in this way. So the electron orbits the center, the electron orbits the nucleus. Okay. Now, you may notice these little pluses and minuses. This is the charge on it. And I like to think of a charge almost like a little bit of electricity. This is more of an analogy, but that's kind of how I think of it. And you've got positive types and you've got negative types. So protons always have a positive charge, and electrons always have a negative charge. Okay? And neutrons, do you see a plus or a minus on it? No, neutrons are neutral. They have no charge. Okay? So, if we were going to follow along in our notes packet here, right here it says, fill out the chart below to help you understand atoms. And subatomic, remember sub right here is going to mean below. You could think of a submarine. And so what's smaller than an atom? What's below an atom? Well, these are the three things. They're going to be protons, neutrons, and electrons. And again, the charge on the subparticle, well, if you're a proton, P for positive, you notice you have a P on proton and a P on positive. That helps me. Neutrons are neutral, which means no charge. And then electrons are going to be negative. Okay. And where's the location? Well, protons and neutrons are in the nucleus, which equals the center of the atom. And then electrons are orbiting the nucleus. Now this path of the electron, this circle that it travels in, that is going to be called a valence shell. That's just a vocabulary word that you have. So electrons orbit outside the nucleus, and they orbit, the path there is called a valence shell. Okay. All right, and up here for define atom, you should have that it is the smallest stable unit of matter. You had that from chapter 1 notes as well. And then if we go back here to define matter, well, you notice in your lesson it tells you right here, matter is anything that occupies space and has mass, and mass is essentially weight. So most things in our world are matter, even if they're super small. An atom is matter, even though it's something that we can't see with the naked eye. Okay? All right, so this lesson continues to go through essentially what I've talked about, so if you need to go back and read that, it's right there. And so let's talk about, there's different types of atoms, and in the last chapter we talked about some different types. Carbon, hydrogen, oxygen, those are all atoms. They consist of a proton and a neutron and an electron, or different numbers of those, but they have these three parts to it. Okay, so it turns out what makes different atoms different from one another? Well, the big difference is how many protons they have. So this chart here is just showing you oxygen. Turns out it has 8 protons. Carbon, it has 6 protons. Okay, so if we were to go to the atom, look in the nucleus, and if it had 8 of these positively charged particles, then we would say, hey, that's got to be oxygen. Okay? And oxygen, it is going to be oxygen if it has 8 protons, no matter if it's got 8 neutrons or 20 neutrons. It's got 8 protons, it's oxygen. If it's got 8 protons and it's got 8 electrons or 20 electrons, it's still oxygen. Okay, the number of electrons, the number of neutrons don't matter when you're naming an atom. Okay. Okay, one thing you'll notice here in this chart, and you have a place to fill it out in your notes so that you get some practice with this, but this right here, the abbreviation column, you should know all of these abbreviations. These are common atoms that you will encounter for the rest of your career as either a scientist or a health professional. And so know these. Some of them are pretty intuitive. Oxygen, the abbreviation for it is just uppercase O. All right, so some of these are pretty intuitive. But what I would do is I would look through this and star some of the ones that aren't immediately obvious. Okay, so for example, we have potassium, and its abbreviation is a capital K. We've got sodium, and its abbreviation is capital N, lowercase a. Okay, so it's important that you might go through here and star the ones that just don't automatically kind of make sense. Okay? All right. The last thing that I want to talk about is this idea of elements. Okay? And an element is really a large group of atoms, so a whole bunch of atoms put together, but there is only one type of atom in that big group, and that's when you call it an element. Okay? All right, so let's go back up to our learning objectives. We have listed the 3 subatomic particles. We've indicated the charge on each part, and we've looked at these different terms. Let's go back to our sheet here and make sure that we've looked at all of these. And so right here, if you were going to define the valence shell, you could look over here, and this really tells you it's the orbit in which an electron travels around the nucleus. Okay?